Now we looked at last time the Pascal's triangle, and also how the coefficients from Pascal's triangle can be found by using combinatorics. So this number here relates to the first number, and then we can figure out whichever number we want here by either putting 0, 1, 2, 3, 4, or 5, and so on. Now we can also work these out as we did in AICE 1 by doing factorials as well. So actually, if I want to work out 5c2, I could actually do 5 times 4 divided by 2 times 1, which would give me 10. Now we're going to use this idea to actually help us to find out more complicated binomial theorem questions. So if I look at a very general expression here, now I got to the power of n here. Now obviously we can't write out every single term because this goes on forever and ever. But if I was to do my 3 terms, certainly the first term is going to be 1 from Pascal's triangle. So I could put 1 times by the first term to the power of n, and then the second term to the power of 0, because n plus 0 is 0. And then the next number from Pascal's triangle will turn out to be n, because it's whichever number we have in the row. So if it's the 5th row, it's 5. So if it's the nth row, it's going to be n. Then we would decrease the power by 1, and for this one we would increase the power by 1. And then for the next one, and this is the one where it's not quite so obvious what it would be n minus 1 over 2 factorial. 1 to the power of n minus 2, and then increase the power for this one, so x squared. Now if I simplify all this, then what I actually end up with here is this all becomes, well, this is 1, this is 1, and so is this, so I just get 1. And we could have known that from the start anyway, just by doing 1 to the power of n, which is how we find our first term. Now for our second term, x to the power of 1 is just simply x. 1 to any power is 1, so what I end up with is n. Now to make this a little easier to see the pattern later, I'm going to put divided by 1 factorial, which is just 1. Now for this our third term, we have n minus 1 over 2 factorial times by x squared. Once again, 1 to any power is just going to give us 1. Now there is a pattern actually within these terms as well. So if we were to carry on here, notice I have 2 terms with n here, just 1 term with n, in fact 0 terms with n here. So this one's going to have 3 terms. So n minus 1, n minus 2, 1 factorial, 2 factorial, 3 factorial. And also my powers of x are increasing as I've been going along as well. So x to the 0, x to the 1, x squared, x cubed. So this is the formula that's actually on your formula sheet for the AICE. So you don't need to memorize that formula. You just need to know how to use that, and I'll show you that in the next example. Now, unlike we did the questions in AICE 1, now we can start to also have negative exponents here as well. So what I had in my previous question was 1 plus x to the n. So this number here is my n. So n is negative 4. And also, instead of having x this time, I have 2x. Importantly, this question starts with 1. This must always work if we want to use that sequence expansion that we saw earlier. So now I just go ahead and plug in all the numbers here. So n is negative 4. Instead of x, I'm going to put 2x this time. 1 factorial is just 1, so I can fill that in as well. Negative 4, take away 1, so negative 4, negative 5. This is 2x all squared, divided by 2. And for our term over here, this is going to be negative 4, negative 5, negative 6. Times by 2x all cubed. And 3 factorial is 3 times 2 times 1, so that's just 6. And I can say these are all times as well. And once we've substituted in, we just need to simplify these expressions. So let's see what we can actually do here. So negative 4 times 2x is negative 8x. Divided by 1 is just going to be negative 8x. Here we've got to be careful because we're going to remember to square everything. So 2x times 2x is 4x squared. Times by 20 here, because negative 4 times negative 5. So that's going to give us 80x squared over 2. And on this over here, we've got 2 cubed, which is going to be 8, times by negative 4 times negative 5 times negative 6. Now, if you can do simplifying as you're going along, you can make your life a little easier as well. So I can see the 6's cancel here. I got 3 negatives multiplied together, which is going to be negative as well. So I got positive 20 times by negative 8 here. So that's negative 160 x cubed. Now I can also go back and simplify this as well. So 80 divided by 2 is 40. And that would be our series expansion for 1 minus 2x to the power of negative 4. Now, I can also do this questions with fractional exponents as well. So here we have 1/4 as an exponent. Now, I said earlier this must start with 1 here if we want to use that series expansion, and this one doesn't. So actually what we need to do here is we need to take a common factor here. So I'm going to take 16 as a factor. The idea being 16 times 1 is 16, so now my series will start with a 1. And 8 divided by 16 is 1/2. And this is to the power of 1/4. Now actually this whole thing is to the power of 1/4, so let me just switch that around there. And often what you'll find with these questions is they chose the numbers very carefully. So 16 to the power of 1/4 we can actually work out, that's going to be 2. So this is actually 2 times 1 plus 1/2 x to the power of 1/4. So we're going to do the series expansion with this because this starts with a 1, and then we're going to just times our whole answer by 2. Now for this one we're just going to find the first 3 terms, so I'm going to get rid of this part of the formula. And often they'll say in the question exactly how many terms they want you to find, but we're going to need to times all of this by 2. So let's start plugging numbers in. So I've got 1. For this question, n is going to be our exponent, which is 1/4. So 1/4. Instead of x, this time we have a 1/2 x divided by 1 factorial, which is 1. And for this one, we've got n minus 1, so 1/4 minus 1 is negative 3/4, times by x squared, but this time it's actually a 1/2 x, all squared, all divided by 2 factorial, which is 2. And then now we just need to evaluate all this. So 1 we're good with. 1/4 times by 1/2 is 1/8, so we've got x over 8 here. What we got here, well, we got a 1/2 squared, which is a 1/4. Perhaps if we multiply the numerators together, that might help for this one. So we got 1 times negative 3 times 1, which is negative 3. I got x squared here as well. Denominators 4 times 4 times, this is 2 squared here, so 4 times 4 times 4 is 64. And then all of that has to be divided by 2 as well. And then now we can start to simplify this too. So if we've got 64, then we're also divided by 64, but then we're also going to divide by another 2, and that's the same as divided by 128. And I think that's as much simplified as we can do. So now we should distribute 2. So 2 times 1 is 2. 2x over 8 is 2/8 x, or that's the same as 1/8, 1/4 x. And 2 I can divide into this one here, which will give me negative 3 over 64 x squared. So no more difficult if it's with a fraction. We just have to substitute in a different value for n and then go ahead and simplify. But going back to that first line, make sure your series starts with 1 plus, because if it doesn't, then we can't do that. So make sure you take a common factor out at the start of a question. And you should now be able to try quite a few of those questions from exercise 14a.